अस्सलाम वालेकुम स्टूडेंट। आज हम चैप्टर 9 फर्स्ट ईयर फिजिक्स में नेचर ऑफ लाइट को डिस्कस करते हैं। नेचर ऑफ लाइट एक्सप्लेन्ड बाय मेनी साइंटिस्ट्स रिमार्केबली न्यूटन, हाइजन, मैक्सवेल एंड मैक्स प्लैंक। First idea given by the Newton that light is a particle or energy bundle nature, but due to lack of practical proof Newton failed. And second idea given by the Christian Huygens, that is light is a wave nature. The practically proof of wave nature are reflection, refraction, interference, polarization, diffraction. All these are practically proof of the wave nature of light. The interference phenomena first time practically performed by Thomas Young scientist. For interference of light, there are three conditions. What are three conditions? Monochromatic lights, phase coherent sources, superposition theorem. Mono means single. The light which carries single wavelength called monochromatic light. यानी हमें ऐसी लाइट लेनी है, दो लाइट वेव कि हर लाइट वेव में सिंगल वेवलेंथ हो। जैसे कि हमारी जो ऑर्डिनरी लाइट है उसमें 7 वेवलेंथ्स होती हैं, मगर हमें चाहिए सिंगल वेवलेंथ की, तो दैट इज कॉल्ड मोनोक्रोमेटिक लाइट्स। सेकंड, फेज कोहेरेंट सोर्सेस। टू लाइट सोर्सेस आर फेज कोहेरेंट इफ दे आर इमिटिंग लाइट रेज एट सेम टाइम विद सेम फ्रीक्वेंसी। दो ऐसी लाइट सोर्सेज हों जो एक ही वक्त में सेम फ्रीक्वेंसी की लाइट्स इमिट करें, मोनोक्रोमेटिक लाइट्स, उनको हम कहते हैं फेज कोहेरेंट सोर्सेज। थर्ड, सुपरपोजिशन थ्योरम। व्हेन टू लाइट वेव्स कंप्लीटली सुपरइम्पोज्ड विद ईच अदर कॉल्ड सुपरपोजिशन थ्योरम। Two light waves are in interference and completely merge with each other, mix in each other, that is called superimposed with each other. This is called superposition theorem. These three conditions are necessary for the interference phenomena of light. Young used two slits, so that's why this experiment called Young double slits experiment. Thomas Young used two slits for phase coherency. These are the two slits as shown in the figure, from which two light waves are coming out at same time with same frequency and are in monochromatic. First we pass a light wave from a single slit. This light from the single slit will be divided in two equal parts by these two slits S1 and S2. So it is written that the scientist Thomas Young performed practical interference of light by using two slits for phase coherent sources. यानी थॉमस ने क्या किया, फेज कोहेरेंट सोर्सेज बनाने के लिए दो स्लिट्स का इस्तेमाल किया। स्लिट क्या है? मिनिमम पॉसिबल नैरो होल थ्रू विच ओनली वन लाइट वेव कैन पास। सो दीज आर द टू स्लिट्स फॉर फेज कोहेरेंट सोर्सेज, एंड फ्रॉम द स्लिट S1 ray 1 is coming, from the slit S2 ray 2 is coming. Both ray R1 and R2 are monochromatic lights. So it is written at here, the experiment states that the single light wave from source will be divided in two equal parts by the slits and got two monochromatic rays R1 from S1 and R2 from S2, both R1 and R2 meeting at P point on the screen. अब स्टूडेंट फिगर में देखें कि suppose कि ray 1 ray 2 meet at the P point on the screen, it may also be meet at this point, this point, this point, this, any point will be P point. We have used this is the P point where ray 1 and ray 2 are meeting. Now ray 2 has covered more distance than ray 1. Look at here, ray 2 is coming from S2 up to here, ray 1 is coming from S1, so ray 2 has covered more distance. For determination how much more path covered by ray 2, we draw a perpendicular from S1 on R2. So we get a right angle triangle. This is the base angle and this is right angle, in which S1, S2 is hypotenuse, this is perpendicular, and S1B is the base, like this. S1, S2 hypotenuse shown by D, S2B perpendicular. This is path difference, that is from here to here both rays are equal. Look at here, this is the path difference between ray 1 and ray 2. So path difference between ray 1 and ray 2. S1B is the base. We need know of the base, so we have not given its any name. S1B base, and this theta is base angle. So we only need of perpendicular and hypotenuse. Perpendicular upon hypotenuse is sine theta, sine trigonometric ratio. So perpendicular path difference and hypotenuse D. So path difference D multiplied with sine theta, path difference D sine theta. So this is geometrical path difference D sine theta. Now draw another triangle at the midpoint of S1 and S2, that is, I have written here A. Draw a line from A point to the screen C and a dotted line from A to P. So ACP is also a right angle triangle in which AC base equals to L, CP perpendicular equals to Y, and AP is a hypotenuse. We no need of hypotenuse, so we have not given it any name. We need AC and PC, that is base and perpendicular, that is the tangent theta base upon perpendicular upon base equals to tangent theta Y upon L, perpendicular Y base L. So tangent theta Y upon L. Now this theta and this theta are so small and same, and the triangle ACP S1B S1 S2B या S1B S2 and ACP, both triangle are symmetry, means both are same, like only difference in shape. If this angle is 10 degrees, so this is also 10 degree. Due to small theta, that is 5, 10 degrees, sine theta and tangent theta will be equal. So we replace sine theta in the path difference by tangent theta value Y upon L. We have path difference D sine theta. By removing sine theta by tangent value Y upon L, dy upon L, path total geometrical path difference 1. Equation number 1. Now ray 1, ray 2 meet constructively. Suppose ray 1, ray 2 meet constructively at the P point. So path difference of constructive interference, that is m lambda. By comparing path difference of constructive interference with geometrical path difference, equation 1 and 2, we get d into y upon L equals to m lambda. We have to derive here y equation. What is y? Y is a width of interference pattern. If it is constructive interference pattern is called bright fringe. Normally interference pattern is called fringe. If constructive, that is the brightness, is called bright fringe. If destructive, that is darkness, is called dark fringe. So y width of constructive interference pattern called bright fringe, L multiply with m lambda and d will divide m lambda L. Here m order of the bright fringes also be shown by MB, Just like Y also be bright fringe for MB, B for bright. Lambda wavelength of the light use L. This is S1, S2 slits to screen distance, and D is the distance between S1 to S2. So this is formula for width of bright fringe. Now suppose that ray 1 and ray 2 meet destructively just like constructively at P point. Now we take the destructive interference. So part difference of destructive interference M plus 1 by 2 lambda. By comparing with geometrical part difference equation 1 and equation 3, we get dy upon L equals to M plus 1 by 2 lambda. Y equals to L will be multiplied with M plus 1 by 2 lambda and D will divide. So this equation is the width of dark fringe, that is Y or YD. Width of destructive interference, that is dark fringe, and M here order of the dark fringe. So student, we diagnose bright or dark fringes equation by M lambda and M plus 1 by 2 lambda. तो इस तरह स्टूडेंट ये हमारे पास YD width of dark fringe, YB width of bright fringe. अब एक हमारे पास एक और डेफिनेशन है इसी में, फ्रिंज स्पेसिंग. स्पेस मीन्स जगह, फ्रिंजों के दरमियान की जगह. व्हाट इज फ्रिंज स्पेसिंग? द डिस्टेंस बिटवीन टू कंसेक्यूटिव ब्राइट और डार्क फ्रिंजेस is the distance between two consecutive bright or dark fringes is called fringe spacing. कोई से भी दो लगातार आने वाली ब्राइट या दो लगातार आने वाली डार्क. अब स्टूडेंट यहाँ फिगर में देखें, स्क्रीन पर जो हम कर रहे थे y is the width, तो वो ये होगा. अगर जैसे हम सपोज करते हैं यहाँ पर कंस्ट्रक्टिवली मीट की तो स्क्रीन पर इसका ब्राइटनेस आएगी, डिस्ट्रक्टिवली मीट करेंगी तो इसका डार्कनेस आएगी. अब होगा क्या कि अगर एक जगह ब्राइट है तो उसके बाद डार्क होगा, फिर ब्राइट आएगा. तो जैसे YB1 फर्स्ट ब्राइट फ्रिंज, YB2 सेकंड ब्राइट फ्रिंज, YB3 थर्ड ब्राइट फ्रिंज. इसी तरह अब आप देख रहे हैं कि बिटवीन टू ब्राइट फ्रिंजेस देयर इज अ डार्क, और बिटवीन टू डार्क फ्रिंजेस देयर इज अ ब्राइट. सो बिटवीन two consecutive bright or two consecutive dark, the fringe, either it is bright or dark, is called fringe spacing. Fringe spacing is shown by delta y. So delta y lambda L upon D. So this is the delta y between two bright, this is the delta y between two dark, this is the delta y between two dark, this is the delta y between two dark. Every bright or every dark between two others is called fringe spacing.